So let's talk about first grade. Students learn to work with a text of a word problem. That is to say, read the statement, identify the givens, build a model to represent the problem, build a numerical expression, evaluate the expression, write the answer. So there are several ways that we develop this further in first grade. Probably the most obvious one is we introduce text. And we do always read it. They can always hit that question mark button to hear it. So we never, a student who cannot read should still be able to solve the problems, but we know that some students can read and are there, that they should all be learning to read, and we want to support them. So you can see we start by having the givens as a picture. So what that means is even if you can't read, the relevant things should jump out at you. And the method, as you can see at the bottom of the screen, is exactly the same as what we've done in pre-K. So the only difference here is that we have text instead of just pictures of birds. We gradually transition from text where the givens are represented by pictures to a text-only problem. So here you can see the relation more than is given with the numeral 2, whereas we still have a picture of 8 planes, or however many planes that is, 9 I think, and 10. And you can see on the bottom of the screen it's the same method of solution and the same model that we used for Maya's kites. The next step in the progression with text is having a picture only for the unit. So now the picture represents a unit, and then eventually we'll go to full text. Something you should also notice on the screen is that we transition from token models to segment models in first grade, and there are a couple of reasons why we do that. So the logic is pretty much the same, but we now draw segments instead of tokens. So why do we do that? There are 2 reasons. One is I was just listing the 14 types of word problems. Some of those types are extremely difficult to do with tokens. In fact, the hardest of all of those types is a change where the original amount is unknown. Something like there were some birds on the branch, 3 flew away, and now there were 5. How many were there to start? So if you give a child tokens and ask them to do that problem, they actually can't do it because they don't know how many tokens to put out. But if you have a segment, you can write a big segment and label with a question mark and say, okay, 3 flew away, so what has to be left? So that's one reason to introduce segments. The other reason is the numbers get big. We don't want to, past 10, it's pretty unwieldy to work with tokens. You're likely to make an error counting. So it's just a slightly more abstract model that is more convenient for some of the more difficult word problem types, and also allows you to work with bigger numbers. Oh yeah, Pablo wants to point out that yes, these segments are always proportional. So if we say 3 and 16, the 3 is really 3/16 as long as the 16. And we changed numbers. I guess sometimes if it's 90 and 1, we didn't perfectly nail it, but we tried to be very careful with that so that we were building number sense appropriately. Maybe I'll just talk a little bit about the segment models here. We have 16 planes and 3, so we make a segment for 16. We show a part of it as 3, and then the unknown is represented by a question mark. We make 16 minus 3. And I should say, for every type of calculation, including the 16 minus 3 here, if the student makes a mistake on the calculation, there will be some appropriate scaffolding. So next we begin, this is, I guess, kind of the final progression. After we've learned text and segment diagrams, we begin to solve 2-step word problems in first grade. So, and then this is going to be our last topic, by the way, other than your questions, which is how we introduce 2-step word problems. So the first thing we do is we just give 2 separate 1-step word problems. Kenji built 17 castles, Bingo knocked down 5 of them. How many sandcastles were still standing? You can see we label the big segment with 17, then 5, then question mark. We make 17 minus 5. After that word problem is done, we show a second word problem. Bingo knocked down 5 more of them. How many sandcastles did Kenji have at the end? And solve that word problem. The next step in the sequence is to just have a word problem that has two questions. Oliver found 30 big brushes and 20 small ones. 40 of them were dirty. How many brushes did he find in total? How many brushes were not dirty? And you need to know the answer to the first question in order to solve the second question. I should say, just to point out, because this is always how the Russian curriculum works, we're trying to do a couple of different things at once. You can see, of course, we're also practicing addition with round numbers, addition and subtraction with multiples. So the next step in the progression is to insert the auxiliary question. So Ruby had 10 orange lanterns and 5 yellow lanterns. She gave 1 lantern to Maya. How many lanterns does Ruby have left? And so in order to solve that question, you need this auxiliary question. How many lanterns does Ruby have at first? So we just add that in. And then finally, a two-step word problem. And so now I'll kind of take you through what the whole thing looks like. Penny caught 5 fish, then she caught 2 more fish, but 3 fish swam away. How many fish were left? So first, we show how many fish there were at first by dragging the number 5. Then we show how many she caught the second by dragging the number 2. And now, so how many fish did she catch in total? And they should drag the question mark because we don't know how many fish she caught in total. And so this is the step of introducing the auxiliary question and realizing that the thing that we don't know that we need to find has to be marked with a question mark. Then we solve that word problem. We make the equation 5 plus 2 equals 7. And then we make a new model out of our existing model. So that question mark gets replaced with a 7. And now we make a model for the second step. So now 3 fish swam away. We don't know how many were left. And now we make an equation to solve the second part, 7 minus 3 equals 4. And then we drag the answer, which is 7 fish.